All right, so before we get into the compositions, I'm going to review just some evaluating functions. I feel like the way this class is, we learn a ton of new things and don't necessarily practice some of that algebra skills that you need to do different things in calculus and in here. And so the first thing we're going to do is just practice evaluating functions. And so if we have this function, 2x minus 3, and we want to find f of 5, what would we do with that 5? Just put it in for x. That's like algebra 1 stuff that you guys learned. So then it's 10 minus 3, which is just 7. Maybe even pre-algebra stuff. When you first started learning about functions. All right, and then the rest of these are kind of different. You're not putting in a number, you're putting in an expression. And so if I wanted to find f of c, what would I do with the c? Same thing, you just put it in for x. The difference is we can't simplify this down to a number. The answer is just going to be an expression. All right, and then same thing for f of 4a. You just put 4a in for x. Everything that I put in for x, I'm going to multiply by 2 and then subtract 3 from it. So then I will do that. Multiply by 2 and then subtract 3. However, they're not like terms, so you just stop at that point. And it seems like people feel really good about that. And then when you go to do 5x minus 1, they get confused because you're putting an x in for an x, and then I don't know. It's the exact same concept, but for some reason it gets confusing. But same thing, we're going to take 5x minus 1. We're going to put it in for x. So that means we're going to multiply it by 2 and then subtract 3 from it. So we'll do, bless you, multiply by 2 and subtract 3 from it, and that is it. All right. Now that takes us into composition or composite functions. So sometimes you're going to plug a function into another function, and that's what we do with composite functions. And there are 2 ways to write composite functions, and they like to put this on the ACT, so it's good that you learn it in Algebra 2 now, because the first time you take the ACT, you will have already seen it. I'm honestly not sure which notation they use, so it would be good to know both of them. One of them kind of looks like fog. So you have that little circle. I drew it kind of big. It's actually a little smaller than that. And then the other one makes way more sense, but you put the g of x inside the parentheses. But both of these expressions are read as f of g of x, which means you're going to take whatever g is, that whole expression of g, and put it in for x in the f function. Now, when I first taught this in Algebra 2, like 20 years ago, my students kept wanting to multiply, and I got so confused about why they were doing that. And then finally, I realized that they thought these parentheses meant to multiply, but they don't. So one time in math that the parentheses don't mean to multiply, just like this didn't. It means you put 5 in for x. It's the same thing. You're going to put g in for x. All right. So one important note is that when working with composite functions, you're going to start on the inside. Now, it does say or the right, and that's because sometimes it's written like this with a little circle, and g is on the right, so we would start on the right. So if you have f of g of x, the first thing you would do is evaluate g of x first. And then the answer from that is put back into f of x. Right, so we're going to do several of these when x has a value. And then we're going to do several where x is the variable and your answer will be left as an expression. Okay, and so for example 1a, well example 1 and 2, f of x is going to be 3x minus 5, and g of x is going to be 2x plus 1. And on a, we're going to find f of g of 3. And so that f is just going to hang out. And then we're going to take 3 and put it into the g function, which means I'm going to multiply it by 2, and then I'm going to add 1 to it. Right, and then hopefully you can do that in your head. 2 times 3 plus 1, what do y'all think? 7. Right, and then f of 7, what do you think we'll do with that 7? Yeah, put it into f. And everything I put into f, I'm going to multiply by 3 and subtract 5 from it. So 21 minus 5 is just going to be 16. So it's not too terrible if you've seen it before, but if you were taking the ACT and you saw that notation, you might just kind of freeze up and not know what to do with it. You might think multiply. All right, let's look at B. So on B, the order of the f and g can move around, but we're always going to start on the inside or on the right. And so we would start with f of 3, and the g is going to hang out. So I'm going to put 3 in for x, which means I'm going to multiply it by 3 and subtract 5 from it. And then that's 9 minus 5, or 4. And then I'll take that 4, and I'll put it in to g, which means I'm going to multiply it by 2 and add 1 to it, which is going to give me 9. Have you guys try C on your own. It's a little different. You're using f twice, but it's the same process. Start on the inside, get a number, plug it into the other one, or plug it back into f. Algebra 2 teachers must have done a really good job. Alright, so check your C with my C. When I was walking around, I think I mostly saw 16. I think maybe somebody had 7, I'm not sure. But double check, make sure you finished it off and put that 7 back into F. Okay, so you guys remember doing that last year in Algebra 2? Okay. Alright, so did you guys do some like the next one where X was X instead of a number? Maybe? Okay, and so it's definitely more challenging. You have to use more algebra, but it's the same idea. So we're using the same f and g from example 1. And so I kind of do the same thing. So if I'm finding f of g of x, I would take what g of x is and put it in my parentheses. And then I would just take that and put it in for x and f. So that means I'm going to multiply it by 3. And then subtract 5 from it. And then for B, we're going to do the reverse. Do you guys think we'll get the same thing? I think F is, no. Yeah, we're not. Just like on this one, we did F of G of 3 and G of F of 3. I mean, we got different numbers. So order matters when you're doing compositions. It's not like multiplication that you can multiply in any order. So for B, I'm going to take F, which is 3x minus 5. I'm going to put it into G. So I'm going to multiply it by 2. And then I'm going to add 1 to it. Alright, so I get 6x minus 9. So a little different. Alright, and then on the back, we're going to do more of the same thing for example 3. The examples are just a little more challenging, except one of them. I wish I would have changed it a little bit, but I didn't. So that's okay. So we have H, K, P, and M, where I still do have two linear, H and M, but then I have a quadratic and I have a radical or a square root graph, or a square root function. And so for A, I'm going to take H, which is 2x minus 3, and I'm going to plug it into K. And everything that I put into K, you have to square, and then add 5 to. Alright, so I probably have shown this to you before. It doesn't feel like we've squared a lot of binomials this year, but I guess we did. When we did Pascal's triangle, we did this. But I love using the shortcut to square binomials. Instead, for me, it's faster than multiplying it by itself. But it's up to you. I don't care, as long as you know how to do it. But if you want to square a binomial, the shortcut is square the first one, multiply these together, and multiply by 2. And then square the second one. That is how I will always square binomials. So if I'm squaring 2x minus 3, I would start off by squaring 2x and getting 4x squared. Multiply these together, you get negative 6x, and then also multiply that by 2. And then when you square negative 3, you get 9. Alright, and then your last step is just to combine those like terms there at the end, and that should be it. Alright, if you haven't already done B, I'm actually going to change it. I'm just going to make it a little more challenging because we did so many linear on linear already. If you've already worked it out, don't worry about it. It's fine. But I'm going to do, it looks like Pong. I'm going to do P of M of X, which means I'm going to take M, which is 3x plus 2. I'm going to put it into P. And everything I put into P is going to go in under a square root. And under that square root, I'm going to multiply whatever I'm putting in by 3, and then I'm going to add 1 to it. Okay, so that's going to be 9x plus 6 plus 1 under there. Oh, my 1 didn't write. And then that's going to simplify just down to the square root of 9x plus 7. And there's nothing we can do. Even if this had been 9x squared, if there's addition or subtraction, you can't break apart your radical. You just leave it. Just leave it like that. All right, and then for C, we're going to do K of P of X. Which means I'm going to take that P of X and I'm going to put it into K. Everything I put into K, I'm going to square, and then I'm going to add 5 to. Now, squaring a square root is way easier than squaring a binomial. What happens when you square a square root? It just cancels out. And you're left with 3x plus 1 plus 5, or 3x plus 6. All right, what questions do you guys have? All right, now I really like how Brian Passwater on this last example used so many different types of functions, so many different representations. So he did a graph, that looks like a piecewise function graph. He did a table. He did an actual algebraic piecewise function. And then he did a function that is written in words. So it's very good to see different representations of functions and doing compositions with them. It's pretty smart. So K is going to be a quadratic function with a horizontal translation of 2 followed by a vertical translation of -3. So let's write that function. We're going to need it to do any of these that involve K. So I know if there is any kind of horizontal transformation, it's going to happen inside parentheses. So I'm just going to go ahead and do some parentheses. I'm going to put the square on the outside. That's how it would be for a quadratic function. So translations are going to be adding and subtracting numbers. So horizontal translation is adding and subtracting inside. If I want a horizontal translation of 2, am I going to add 2 or subtract 2? Good job. So it's the opposite of what you think. And then the vertical is the same as what it looks like. Okay, so now we can do all these problems. All right, so we're going to do f of g of 3. So f's going to hang out for a second. G of 3, we are going to go to the table of values, that is g. And g of 3 is going to be 5. F of 5, we're going to go to the graph and find the value of the function when x is 5. This is a weird situation. Does the graph have a value when x is 5? No. The open circle means it's not there. So that's okay. That happens sometimes. What do you think that means? Say it again? It does not exist, or undefined is a little bit better terminology, but yeah, undefined. That happens. That's okay. All right, for B, we're going to do h of f of 8. So f is the graph. We're going to go to where x is 8. What is the value of the function there? -1. Nice job. All right, and then h is the piecewise function that is in algebraic form. So you have, for -1, you have to decide which piece to use. What do y'all think? For -1. The top piece, because -1 is less than 1. We're going to put it into this top piece, which happens to be the most complicated out of them, but it's okay, it's doable. All right, so it's the absolute value of -7 minus 3, or the absolute value of -10, which is just 10. Okay, I'm going to do one more with you. I'm going to let you guys do some on your own. So we're going to do g of k of 0. All right, so k is this function that we had to create ourselves from the words. So k of 0 means I'm going to go through, I'm going to make x 0, and then just simplify it down. So you might be able to do that in your head. If you can't, it's okay. Just take it step by step. You would need to square -2 and then subtract 3. So we want to find g of 1. And then g is the table. g of 1 is 2. Okay, so you guys try D through F on your own. I don't think anything weird happens on these. It's regular. It's over.
Is it during homework?
Yeah.
Okay, that's fine.
So when you guys go to find f of 2, you have to make a decision. It's only going to have one value, so you have to decide between the closed circle or the open circle. Always choose the closed. When you guys go to do your assignment and you're checking your answers, it does say that you need to show your work. You can't just, on a problem like these, just write the answer. But there's very minimal work to show, so like just, I'm okay, like even here, if you do that in your head, but write down what you get when you do that, and then do f of 2. So really, you just have to show stuff like that. You don't have a ton of work to show. All right, what questions do you guys have?